Good morning. I'm coming to you today from my calibration trailer. I'm doing work and school at the same time, two birds, one stone. I'm going to demonstrate how to calibrate electronic counter. Electronic counter is a way to measure frequency coming from a power source. I have one plugged up right here, which I'm going to be calibrating, but I also have one unplugged so I can show you what I'm doing on the equipment. Alright, first things first, I always have to get the specifications for what I'm doing. It's going to be hard to read in the little time I showed you that, but I'm going to read it to you. First, we have to check the actual time base. The time base is where this counter gets all of its accuracy. And usually it's just a standard time base, but it's usually good to plus or minus 10 hertz or better. So in order to check this time base accuracy, we check it with our GPS, which acquires the 10 megahertz frequency from at least 8 different satellites, and it compares them and gives you a perfect reading, or damn near perfect reading. We are going to hook our 10 megahertz reference into our electronic counter to make this measurement. Our electronic counter will then have the accuracy of the frequency we acquired from the 8 satellites. So, in our operations manual, for calibration procedure, I might add, it says that we need to hook this into our external reference of our counter. Our external reference is going to look similar to this. Reference in. So, I know this is already hooked up to the back of this because I did it myself a few days ago. So it's already hooked up and already has the frequency reference it needs. Now, what I need to do now is get my 10 megahertz reference out, from the counter which I'm calibrating and hook it up to my counter. In order to do so, I get a BNC cable, which hooks directly up to the inputs that I showed you, and the input outputs that I showed you. And I'm going to go on my counter, hook it up, and I got to see what it reads. Now, my reading is 9.99999.9. That means this electronic counter is within 0.1 hertz of what it is supposed to be nominally. So that's way good, so I'll press on. The only other thing we really check on these counters is to make sure that the inputs going in, there's 3 inputs, channel 1, channel 2, and channel 3. These inputs have input specifications on the amount of power that it takes to generate a frequency on the display. So I look back at my spec sheet and I see that, let's see, channel 1 has an input specification of 20 millivolts or less, and from DC to 100 megahertz. And it has 30 millivolts or less from 100 megahertz to 200 megahertz. And then from 200 to 225 megahertz, we have a 40 millivolt or less input specification. To check this, I go up here on my arbitrary waveform generator, and I'm going to set it for the specifications that are needed. I'll move my camera over a little bit. So, I'm going to go to amplitude, and I know I need 25 or 20 millivolts or less for the DC to 100 meg on the channel 1. So I will go to 19 millivolts just to make sure I'm good. If it's good at 19, it's obviously good at 20. So I'm going to start out with 100 hertz. Now, once I have that set up, I'm going to disconnect my BNC cable from the back of this. and hook it up to channel 1 and also to the output of my generator. My generator is now set to on. Now that I have mine hooked up, that is what it's supposed to read. I know it's hard to see because of the pixelation on the phone, but it's reading 100 hertz, and that's all I needed to read. And then all I need to do is go through all the frequencies and make sure they read right for the minimum input specification power level, and then make sure I check both AC and DC, and it's just a little button on the side right here that says AC and DC. After I do that, I will check channel 3, and this will be a fully calibrated, ready to go item to check frequencies on radar systems. Thank you.